For beginning a new unit, we're going to be looking at linear relationships. So the first thing we're going to talk about in this video is constant rate of change, our essential question, why are graphs helpful, and our I can statement, I can explain proportional relationships with a graph. When I talk about graphs, we're talking about the coordinate plane with your x and y axis. Linear relationships are relationships that have straight line graphs. For example, in this situation, when we talk about the time for a download and the number of songs downloaded, you've got your x, which is your independent variable, and your y, which is your dependent. So let's look at the graph that matches this particular information. Notice we have the x-axis, the time for the download, and then the y-axis, which is the number of songs that are downloaded. Those ordered pairs, when they're graphed, when connected, make a straight line. So this particular situation is an example of a linear relationship. They all fall on the same line. Okay, we're going to look at that same situation with the time for the download and the number of songs downloaded, our x values and our y values, and we're going to talk about that rate of change. If you notice, the change in the y's are increasing by 2 every time, and the x's are increasing by 1 every time. So as you notice that the number of songs increases by 2, the time will increase by 1. We can make a ratio for each of these situations. Your ratio for rate of change will be the change in y, which in our situation here will be the +2, over the change in x, which again in this situation we have a +1. So if you notice, each time we have 2 over 1, 2 over 1. So all of these represent their own ratio. So what that means is there's an increase of 2 songs every minute. So another way to say this is that our rate of change is that 2 songs were downloaded per minute. What we also notice in this particular situation is this set of ratios that I just wrote is consistent all the way through the graph. When that happens, when your rate of change is the same throughout the entire set of ordered pairs, then you've got a linear relationship because you have a constant rate of change. When you have that constant rate of change, that means that your relationship in the table is a linear relationship. Let's look at some examples and observe the rate of change and determine if it's going to be a constant rate of change, which would make it a linear relationship, or if it would not be constant, which on the other end means that it's not a linear relationship. In this particular situation here, we're talking about cooling water. So we've got the time in minutes and the temperature of that water. Your time is your independent or your x variable. Your temperature is your dependent or your y variable. So remember that rate of change is the change in y over the change in x. So we're going to make ratios for each of these situations as we go along. Let's look at the y's first. When we go from 95 down to 90, we have a drop of 5. And for the time, we went from 5 minutes to 10 minutes, so that is an increase of 5. So the ratio that represents this first set of changes would be -5 over +5, which is a -1. The next change we see, we're going down 4 and up 5 for the x's. So this is actually -4/5. or negative 0.8. Then for the third situation, we are again going down 4 and up 5. So we have another negative 4/5 or negative 0.8. What you want to observe from this table is that these three ratios or rates of change are not all the same. You have two that are the same, but that's not going to make a difference. You want all three of those ratios, or how many that you have from the table, all of them need to be consistent, the same rate of change. In this situation, it's not. So, in this situation, this is not constant. This is not going to be linear, because those rates of change are not the same all the way down. Last example, you may see a relationship in graph form. For instance, this situation with the number of volunteers, which is your X, and your time in minutes. So I'm assuming we're talking about the time to get a job done depending on how many volunteers that you have. For instance, the first point is at 8 and 80. What that means is, 8 volunteers, it will take 80 minutes. When there are 16 volunteers, it will take 60 minutes. So the more people that help, the less time it's going to take. And if there's 24 volunteers, it's only going to take 40 minutes. Let's check to see if this represents a constant rate of change or a linear relationship. Let's look at the change in Y's. Remember, volunteers are your X's, time is your Y. We're going down 20 minutes for every 8 volunteers that are added. We're going down 20 minutes for every 8 volunteers that are added. So the two ratios we have, negative 20/8. And in the second situation, we also had negative 20/8. Since that is the same ratio, this will be a constant rate of change, which means that this is a linear situation. If I take a ruler to this, we will get a straight line with those 3 points. They all fall in the same line. That is a linear situation. So you can determine if it's linear by looking at those rates of change and seeing if they're the same all the way down. We're going to do more examples in class.